Hey everyone, I already discussed how to find functional dependency closure and attribute closure. Today I'll discuss some more examples based on that. Example 2, some functional dependency given and it is asking for finding super key. Super key means you need to find the minimal super key. How can you find the super key? For super key, we need to find attribute closure. Which attribute closure contain all the attribute that is the super key. First, we will find A positive closure. A positive closure will be A. From A, we can imply B, so B. Then B implies C, we can write C. B implies F, we can write F. F implies H, so we can write H. A positive closure is A, B, C, F, H. Next check B positive closure. B positive closure will be B, C. From B, C, F. From F, H. But we cannot derive D. From A also we cannot derive D. Next check D positive closure. D positive closure equals to D, F, H. Now C positive closure. C positive closure equals to just C. So maximum we found from A positive closure, just D is missing, so what we can do, we can find A D positive closure. A D positive closure will be A D first, then we can add B as A implies B, then from B we can derive C, so A B C D, then from D we can derive F, A B C, even from B C we can derive F, so D F. From F we can derive H. A, B, C, D, F, H. We are able to derive all the attribute from AD positive closure. That's why minimal super key will be AD. So first try to find attribute closure of all the single attribute. If from the single attribute you cannot find all attribute, then combine 2. If from 2 attribute you cannot find, then combine 3 attribute. Like this you need to check. And A positive closure equals to A, B, C, F, H means from A we can implies B, C, F, H. So this also hold. Means we can write A implies B, A implies C, A implies F, A implies H. So all these hold. Then B positive closure equals to B, C, F, H means C, F, H are functional dependent on B. D positive closure equals to D, F, H means F and H also dependent on D. C positive closure equals to C, F positive closure equals to F, H due to this functional dependency, and H positive closure is H. So maximum we can derive from A positive closure, just D is missing. So that's why we just combine A, D to find the super key. And A, D positive closure equals to A, B, C, D, F, H. So super key equals to AD. And this is our minimal super key. If it is asking find number of super key, okay, any superset of this candidate key is the super key. So AD are the prime attribute, rather than AD there is B, C, F, H. So there are 4 attributes which are non-prime. So how many combinations possible? 2 power 4. Power set of 4. 2 power 4 equals to 16. AD is our candidate key, or we can say minimal super key. A, B, D, A, C, D, or suppose A, B, C, D, A, D, F. Any superset of this, okay. A, D, H, all are the super key. So total there can be 16 super key possible in this example. Next example, some functional dependency given and it is asking to find the super key. Here also super key means you need to find the minimal super key. Now in LHS, AB, BC, D, C, F. So except D, all are 2 attribute. First we will find AB positive closure. C is dependent on AB. So A, B, C. Then B, C derive AD. You can add D here. D derive E. Right? E here, then C, F implies B, but there are no way to derive F from AB, right? So AB is not the super key. Now check BC positive closure. BC positive closure will be A, B, C, D, E. Here also we are not able to derive F. Next AD positive closure. AD positive closure equals to A, D, E. From D we are deriving E. CF positive closure, that is A, B, C, D, E, F. From CF we are able to derive all, that's why CF will be the minimal super key. So CF positive closure equals to CF. From CF you can derive B, so it will be BCF. Then from BC you can derive AD, so A, B, C, D, F. Next from AB you can derive C, C is already there. BC you can derive AD, AD is already there. From D you can derive E. So A, B, C, D, E, F. Now all attributes are here, A, B, C, D, E, F. Hence CF is the minimal super key. Here also this is the minimal super key or candidate key. If it will ask find number of super key, then rather than CF there are A, B, D, E. There are 4 non-prime attributes. So 2 power 4 it is 16. There can be 16 super key possible. So all the superset of primary key or candidate key are the super key. Next example 4. Some functional dependency given and it is asking to identify these functional dependency exist or not. For that what we will do, we will find left side closure. If it contain right side, then that is possible. D plus equals to A, E, H, then from A, B, C, then E. So it can derive all the attribute, that's why super key equals to D. Now check all these functional dependencies. So we need to find A, D plus, A, D plus. From A, B, C, then D is there. Then from C, D, we can derive E. From E, C, C is already there. From D, A, E, H, E is there, just add H. Then A, B, H, B, D, B, D is already there. D, H, B, C. So A, B, C, D, E, H. And it is saying A, D derive H. H is at right side, hence this is possible. Next, DE implies B. Find DE plus. If right side contain B, means this functional dependency possible. From D, A, E, H. A, D, E, H. Next from A, B, C. So A, B, C, D, E, H. Then from C, D, E is already there. From E, C, C is already there. A, B, H, B, D, B, D is already there. D, H derive B, C, B, C is already there. D, E derive B, B is at right side. Hence this is possible. This is true. Next dependency B, H implies A. So find B, H positive closure. Now from B and H we can just derive B, H because there is no other possibility, we cannot add any more. And right side is A. Is there any possible that we can derive A? No. Hence this is not true. Next AB derive D. So AB plus, from A you can derive BC. So A, B, C, just A, B, C. We cannot derive D. There is no possible way we can derive D. We might derive BD from ABH, but there is no H. We cannot derive D from this. Hence, this is also not true. So, whenever any functional dependency given and it is asking to check whether it is possible or not, just find left side attribute closure. If right side attribute is present, then that is possible, else no. Next example 5. Some functional dependency given and it is asking find primary key and number of super key. Okay, now for number of super key we need to check how many non-prime attribute there and what will be its power set contain, that many super key possible. So let me first find what will be the primary key, or you can say candidate key or minimal super key. A plus equals to A, B, C. Then E plus will be from E you can derive C. So just E and C. Next D plus, D positive closure, from D you can derive A, E, H. So D, A, E, H. Next from A, B, C. So A, B, C, D, E, H. Then from C and D, E is already there. From A, B, H, B, D already there. From D, H, B, C is already there. So from D you can derive A, B, C, D, E, H. And these are our all attribute, hence D is our primary key or you can say candidate key. Now non-prime attribute, rather than D there is A, B, C, E, H. There are 5 non-prime attribute and power set will be 2 power 5, that is 32. It can be any combination of these A, B, C, E, H. So total number of super key will be 32. D combined with any of these, that will be one super key. So any superset of primary key or candidate key is a super key. There can be 32 possibility combination of non-prime attribute. Hence total 32 super key possible. In 2022, one question was asked on this. It was asking how many super key possible. So first you need to identify what is primary key or candidate key. Then superset of that, how many superset possible. So check the non-prime attribute and find the power set of that. Okay. In today's lecture, I discussed some example based on attribute closure. If this lecture is helpful for you, please like, share and subscribe. Thank you. Bye bye.